A copper wire of resistivity 1.63 into 10 power minus 8 ohm meter has cross-sectional area of 10.3 into 10 power minus 4 centimeter square. Calculate the length of the wire. Calculate the length of the wire required to make a 20 ohm coil. 2016 exam question. A copper wire of resistivity they have given, cross-sectional area they have given, find the length of the wire to make 20 ohm coil. Tamanna, can you see the screen? Bhavi, Kiara, can you people see the screen?
Yes, ma'am.
Okay. Try now. First tell me which formula I have to use. R is equal to rho into L by A. R is equal to rho into L by A. Okay. Now, what and all values he has given, check what I have to find. Find it now. Okay, tell me first what and all they have given the data. Check what is they have given. What is 1.6 into 10 power minus 8? Read again. Aditya, what is the data they have given? Rho is equal to resistivity they have given. That is rho. That is 1.63 into 10 power minus 8. What is given data only if you write mistake? How you can do the problem correctly? Then what else they have given? Area is equal to? Tell me. Area is 20 ohms. 20.3 into 10 power minus 4 centimeters square. Then what else is have given? R is equal to how much? 20 ohms. And listen here, he has not given the diameter here. Area directly he has given. Okay. And area is in centimeter square. But we want everything in meters. So that should be in meter square. So area, I can write it as 10.3 into 10 power minus 4 into, since it's square, see from meter to centimeter to meter, if you convert, it is multiplied by 10 power minus 2. Correct? So since it is square, right, I have to multiply by 10 power minus 2 into 10 power minus 2. Okay. Understood or not? See, I have to convert from centimeter to meter. Okay. Okay. So what I will write, 1 centimeter, I can write it as 1 by 100 meters. That is 10 power minus 2 meters. Correct? Here we have centimeter square. Area. Yes. Not separately length the diameter. So if I want to convert into meter square, instead of multiplying once 10 power minus 2, you have to multiply 2 times. Okay. Now substitute the values. R into A is equal to rho into L, or L is equal to R into A by rho. Now put the values and calculate. All exponentials, keep it separately. Do that separately. The numerical value separately and calculate. 126. 0.3 meters. Correct. 1 or 2 are doing. What about other people? And every day you should go home and read. You got the answer?
180. This is correct. Equals to 8.
Which one? 10.3.
10.2 to 10 to the power minus 8.
Correct. R you have written 10t into 10.3 divided by 6.
1.60.
Correct. Exponentials separately.
Exponentials I cancel it.
Everything will cancel.
No, ma'am, exponential the same value. Minus 8 down also minus 8.
Same thing will get.
Yeah, ma'am.
Okay. 20. I have not checked. That's why I asked.
And here you will get minus 8 now, ma'am.
Correct.
Here 1.63.
Correct. It will cancel. Good. Minus 2, minus 6, minus 8. Correct. Good. Divided by rho is 1.63 into 10 power minus 8. Yeah, I can cancel these two. So this you have. Rohit Pawan, right? Tell me the answer. A wire of resistance 5 ohms. It is bent in the form of a closed circle. Find the resistance between the 2 points. Between the 2 points at the ends of any diameter of the circle. Diameter of the circle. Think and do. This one. This is also exam question 2020. Resistance. Resistivity is rho. A wire of resistance 5 ohms is bent in the form of a closed circle. So one wire is there like this. Think. Okay. So one wire is there. Its resistance is 5 ohms. It will have some length L. Correct. Now I am trying to bend that into a circle. Same wire, straight wire, I will bend into a circle. So I will bend this into a circle. Now find the resistance between the 2 points at the ends of any diameter of the circle. So I will take this is one ends of consider like a circle. This connection is not there between the 2 diameters you will have. 2 diameters you have to take. This is point A. This is point B. Okay. So now what is the resistance between A and B? He is asking. Here you can consider this is one resistor of length L by 2. This is one resistor of L by 2. Correct? See, same wire, area of cross section is same. So what we have, R is equal to rho into L by L. Correct? No. Now this R he has given 5. Rho is same because same wire only I am using. And area of cross section, it is also same. But length, this you can consider like 2 resistors which are in parallel. Correct? Because they are connected between the any 2 points. So I can consider two resistors of L by 2 which are in parallel. So this, it is something like this. Can think like this. And length L by 2, length L by 2. Everything else is same. Length I have reduced by L by 2. So what will be the resistance? It will be 2.5 ohms. Both will be 2.5, 2.5. Correct? Now, two resistors are in 2.5 and 2.5. So find the equivalent resistance. Resistance 2.5 ohms. This is also 2.5 ohms. Okay. Again, I repeat, see, one length of wire is there. Its resistance 5 ohms. Okay. I will bend into a circle. Then between two diameters, I am trying to take the resistance. So this I can consider as one resistor. This another resistor where rho A is same for both, but length will become half. L by 2, L by 2. So you can assume like this. Since L by 2 is that, see, for the same thing, what will be the resistance? It is rho L by. Now, same, everything is same, length has become half. So resistance also will become half. That is 2.5, 2.5. Now, two resistors in parallel, which are 2.5 and 2.5. Fine, are equivalent. What is the value you are getting? R equivalent? One by R is equal to 1 by R1 plus 1 by R2. So 2.5 here, it is 2. So R equivalent will be 2.5 by R equivalent will be 1.25 ohms. Okay. It is asked in 2020. Huh? You can just write since the length of each resistor becomes L by 2, so resistance will be equal to, or you can write this as R1, R2. R1 will be equal to 5 by 2, that is 2.5. Right. Four resistors. Sunaina, try this. Four resistors of 4 ohms each are joined end to end, to form a square. Calculate the equivalent resistance. The equivalent resistance of the combination between two adjacent corners. Try this. This is also exam question 2016. Now, calculate equivalent resistance of the combination between two adjacent corners. Four resistors are in the form of square. So first thing, it is in the form of square. And where you have to find the equivalence of the combination between two adjacent corners. One after the other, like that, adjacent corners means. So A and B. And mark this as A and B. Total 8 ohms. No, all are 4 ohms he has given like this. Find equivalent resistance. 1 minute. Equivalent resistance between A and B. This is the question. What I've done, I've just checked. Understood? No. Between A and B, I have to find the equivalent resistance. See, first what he has told, four resistors. Four resistors. Okay. Four resistors are in the form of a square. They've told. You have to find equivalent resistance of the combination between two adjacent corners. Two corners next to each other is there. So I'll take A and B. Okay. Now between A and B, I have to find the equivalent resistance. So whenever they ask like that, like from the other end, you try to solve. Okay, so this portion is also connected, no? So this end also connected to A. Here also B. So equivalent you should find. You should solve all.
That's also not four.
No, it is not 4 because here also another connection is there, right? This also you should solve. See, if I call this as R1, R2, R3, R4. Okay. R1, R2, R3 are in series, as you told. Correct. Okay. So I can replace all the three. See, between A and B, I will get all the three. So I can remove all the three and I can put one resistor between these 2 points. Correct. So I'll get 4 plus 4 plus 4, 12. I can write like this. Correct. Now, between these two, you have to, which are in parallel. Say how you have to check is between any 2 points, I can replace 2 or 3, whatever is there, I can replace and I can put like that. You have to check. And if he's asking between A and B, means from the other side, you should try to solve. Always like that. Okay. So now all the three, instead of all the three, I can put between A and B, all the three together, which are in series, I will get 12 ohms. So this, always what you try to do is try to write 2 or 3 diagrams, you will understand. So 12 and 4 are in parallel.
Mom,
Huh.
3 ohms.
Huh. So what you will get, 1 by 12 plus 1 by 4 is equal to 1 by R3. So this is 12 here, 1 plus 3. So 4 by 12, 12 RP will be 3 ohms even. 5 resistors are connected in a circuit as shown in figure. As shown in figure. Find the ammeter reading. Find the ammeter reading when the circuit is closed. When the circuit is closed, then find the equivalent resistance. Find the equivalent resistance between A and Do it now. First, find equivalent resistance between A and B. Everyone. Bobby, do this, Kiara. This is the given. First, find equivalent resistance between A and B. What I told, whenever you want equivalent resistance between A and B, from the other end you try to solve. Okay, right. See, if I remove R1 and R2 and if I put this lead where I will connect, it is in between these two, correct? So I can't, these two are in series, correct? I mean, I'm telling this is series. But if I remove, if I put one resistor, where in between I can connect this lead, that also I should check. No, I can't disturb the whole circuit. Correct, right? So what I will do, I will take these two resistors first, 1 and 2. R1 and R2. R1 and R2 are in series. Okay. So 3 plus 3, 6 ohms. Now this 6 ohms is in parallel with R3. Okay. So this. Okay. Now this, if you want, you can name it as RS1 6 ohms. This is 6 ohms. Now this is 3 ohms. Again here, yeah, I can remove these two and I can make parallel. 6 and 3 parallel, how much you will get? 2 ohms. So 6 ohm is in parallel with 3 ohms. You will get 2 ohms. This 2 ohms, I can replace, only 2 are there. There is no other something extra leads which will disturb. So I can remove these two and I can put one resistor 2 ohms. Now this is 0.5 ohms and this is also 0.5 ohms. Okay, so here positive, negative, positive, ammeter, key, like this. Now, here in between, you don't have in between some resistor here. So I can remove all the three and replace between A and B. Okay. Huh. So 0.52 and 0.5 are in series. So 3 ohms. So the circuit will be like this. Write 2 or 3 like this, you will understand. Otherwise, you will get confused or you will do mistakes. Then you will not do mistakes actually. So you will get 3 ohms. So R equivalent will be equal to 3 ohms. That's what I told. If you want between A and B, from the other side, try to do. We don't have, yeah. Okay, like this. Now, he is asking to find the current in the circuit. This is 3 volts, okay. Now, he is asking what is the current in the circuit. In this equivalent circuit, what you will get? Current 1. Because equivalent resistance is 3 ohms. Okay, resistance is 3 ohms. Voltage is 3 volts. So, current will be V by R. So, 1 amps. Okay, so always remember main thing, if I want between A and B, from the other end, I have to try to solve it. Okay, the first thing. Then you have to remove the resistor such a way that it should not disturb others. See, these two are in series, but if I remove this, it means another 1 point. If I remove these two, if I put another resistor, where I have to put this lead, I don't know. So I can't remove these two resistors. So I have to start replacing the resistors where it will not disturb the circuit. Okay. That's why we have to do like that. Understood? Someone is writing. Finish it. We'll do another four. How would you join? How would you join 3 resistors, each of resistance 9 ohms. So that the equivalent resistance of the combination is first one 13.5 ohms, second one 6 ohms. See, three resistors are there. Okay, 9 ohms. Like this, three resistors they are given. So you have to connect somehow parallel, series, both series, parallel, anything you can do. But you should get one time combination 13.5 ohms. Second time, if you connect in a different way, answer you should get 6 ohms. So how you will connect three resistors? Understood? No question? 2000. Pavan understood? First 10. Do it now. Anyone you can try. Try anyone. It's fine. So either you put all the three series, all the three parallel, one series, two parallel, one series. Anything you want, you do. But they will give three resistors, each one value 9 ohms. The equivalent resistance I need once 13.5 ohms, second time 6 ohms. Okay. Do it, Kiara. Do. Try different methods. One or two you will not get fine. Try the third method like that. Three resistors are there. You can think it as R1, R2, R3. Do three resistors. All the three in series 9 plus 9 plus 9, 27. I don't want that, so I can't do that. All the three in parallel, you will get 3 ohms. That also will not work. So either two series, one parallel, or two parallel, one series should be there. Now, I will put two in parallel. Okay, one in series. Okay. 9 and 9 are in parallel. I will get 4.5 ohms. Calculate, you will get this. Half of that you will get. Okay. So this is 9. See, two are in parallel. Huh? Okay. So 4.5 ohms you will get. Another one with 9 ohms. So you will get 13.5. See, first time you will not get, but you should try with different values and try. That is. Okay. So, next one, two are in series with third one in parallel. Like 9 series, you will get 18 ohms. Then another with like. So you will get 18 and 9 in series, you will get 6 ohms. Okay. Here, put one thing first. You should mention, otherwise, how you will which 2 points you are taking? Between which 2 points? Okay. Understood now? This is 2018, they had asked this question like this. So think of what are the possible ways. Okay, in mind only you can do series parallel, then you can try with the other. Okay, tomorrow we will continue. Okay, that's bye. And few.
Here we will end the today's class. Do not forget to subscribe the channel. If the content of this channel is useful, please like the video and share with your friends. Thank you.